Welcome to this series of assignment. 10th class Science, Light and Reflection. IDP is 842319ZD. Basically, this assignment deals with the long answers questions. Question number 1 is shown over the screen. Now, in this question, what we find, there are 5 of parts. So, let us go through this question quickly. Draw ray diagrams showing the image formation by a concave mirror when an object is placed. So you have to draw ray diagrams for 5 different positions. One, when object is between pole and focus of the mirror, then between focus and center of curvature of the mirror, then at center of curvature of the mirror, B, a little beyond center of curvature of the mirror, and lastly when it is at infinite or infinity. So well students, as we have discussed earlier also, when you go for such a drawing or ray diagram, I should say rather, be very careful about distances. The distance from P to F, so this distance, when I say this distance, this should be just equal to what we find here for C and F. As you are aware of, C is equal to, or R rather I should say here, this is because this is up to this place, C to P. This is radius of curvature. This is radius of curvature. And in blue, if you see here, this is focal length, right? And as we know that radius of curvature is double of focal length. So when we write here, it becomes R is equal to double of focus. So 2F, right? So be very careful about these things. So now when we go for this particular five options so first we'll start with A, between pole and focus of the mirror. And if you remember, we have already earlier we have discussed that when we go for such a figure, we have to keep 3 or 4 things in mind. Firstly, a ray of light which is parallel to C. When I say a ray of light which is parallel to C, that is not C rather, this is the principal axis. That is, this is called principal axis. So any line, any ray rather, which is parallel to principal axis, let us say this ray is parallel to principal axis. After refraction, it is going to pass through F. Remember this. So this is the first important parameter which you must keep in mind always. Always make this diagram with a very sharp pencil and use your scale very intelligently. So this is number 1. So when I say a ray coming parallel to principal axis, so this is a ray coming, and after refraction it is going to pass through F. Second thing which you must keep in mind, any ray of light which is coming from passing through F, just to make you understand, we start, okay, we'll have the same point of origin here. So any line which is passing through F, any ray of light passing through F is going to become parallel after diffraction. So this is point number 2. And third important thing which you must keep in mind is a ray starting from C and hitting anywhere on the aperture of the lens here is going to come back on the same path. So then it is going to come back on the same path here like this. So these 3 rays you can use, but depends at which case you are going to draw. And the fourth one in which you have to be very, very careful is when you start origin from here. I'll just change the color. Let's see the fourth mechanism. Start from here and let it hit this concave mirror at P. And as you are aware of, this angle is angle of incidence. And after reflection, correction, we have to use the word reflection here. It is not a case of refraction, this is reflection. That is, why reflection? Because ray of light after hitting the concave mirror coming back in the same medium. So here we are. So when we take it here, so it is going to make equal angle, that is R. As you are aware of, angle I, this is angle I, this is angle I, and this is equal to angle R. So I and R are always equal. So angle I is equal to angle R. But while making this, you have to be very careful because this angle must be equal to this angle. So you can always use your service protractor for measuring correct angles. Otherwise, you may make a diagram which with some small error. So there are 4 parameters which I have told you. Firstly, a ray of light going parallel. So it is going to pass through F. Secondly, when it is passing through F, it is going to become parallel. Thirdly, anything starting from C will hit the aperture and come back on the same path. It may be here, anywhere, not necessarily you should hit like this. It may be like this also. Let's say it starts from here. It starts from here, right? And it is hitting it like this here. So I think it's slightly going away from the lens, this correction mirror. So like this, or anywhere you can say. Matter of fact, take anywhere, but it must come back on the same path. So anywhere it must come back on the same path. So these, and the fourth one which I have told you, angle of incidence, that is I is equal to R, and then you can very intelligently use this particular, just hit it like this and let it go back in the same medium like this. So any of these 4 parameters are equally useful. So that's how you must go through this very carefully, then only you will be able to do this question properly. So let's start with our first case now. Between pole and focus of the mirror. So between pole, this is pole and this is focus. So when you find a ray of light over here, correction, the not ray of light but rather your object like this here. So let me just to make a distinction, we'll just put it a arrow over this, as usually you find in all the books. So like this. So this is your, let's say, object O, and now where it is going to make the image. One more thing which I want to bring to your notice is that this mirror will be a complete mirror, or you can represent it as a mirror if you show that it has got, because this is the surface where reflection is taking place, this side left, and if you show it like this, then it means that the polished side is on the other side of this mirror. So be careful about these small things because they are important. So now it shows that reflection is taking place on this side, not this side. So be careful while attempting these questions. Otherwise, very simple mechanisms, but we have to take care. So now first case we start with, image formed will be where. So as we have discussed earlier also, we start from here. We take a ray parallel to principal axis, and after reflection it is going to pass through F. So straight away we'll, with the help of a scale, we'll draw this. As I've told you, this is not a ray. Ray it will become once you show the direction. So now it is a ray of light without these 2 signs, this arrow. So you must be very careful. Second thing is, let's say this ray passing through F, and second we take this particular thing into account. Let us say the ray of light passing through C, right? Like this, as I've told you. So a ray of light which is going to hit like this. So it is going to, if it is on C like this, then this will go straight here and then going to come back on the same path. So there is no possibility of these 2 rays meeting anywhere because they are now moving away from the away from each other. So here we are that this ray of light after reflection, it is coming back on the same path. But these 2 rays of light they will look like as if meeting somewhere beyond this mirror. Slight error we have done, I believe, but anyhow, you will be able to do it with the help of scale without much of problem. So if I take it here, and let's say it will look like that is as if these two rays are coming from behind the mirror, like this. So then it is very clear that the image which is going to be formed here is going to be, let's say, because why to have a small error here, so it will look like as if it is coming from this point. Remember one thing, when you show it here, these lines, these rays here, they should be shown in dotted form. So remember this, they have to be there in the dotted form. So always represent them in dotted form. So here it is. So now here we find it reaching. So now it's very clear that this image is going to be formed here, first case. And since this point moves from this place to this place, so head, this arrow is towards like this. So image is, let's say object was AB, so image is A dash and B dash, right? This image will be, of course, erect, number one, and this is virtual, because as I've told you, don't show it like this, just show it like with a dotted line, because actually these lines, these rays are not meeting anywhere. Really speaking, they are moving this side, but if you bring your eye over here, then you will find that I will see it as if it is coming from B dash and A dash. So image is erect, number one. Number two, large in size, bigger. And number three, it is virtual, because rays of light correction, they are not meeting, but they are appearing to coming from these points. So first note it down carefully. Then we move towards for our second case. Now second case is between focus and center of curvature. This is focus, and this is center of curvature here. So let's say it is somewhere here. Object is placed over here. So this object, again same parameters will take. First ray of light is going to be parallel, and after this it's going to pass through F, simple. And second, we take another thing into account, that it is passing through F, and once it hits the, after reflection, it comes back like this, becoming parallel to, almost, we have to be very careful. You can always use that reflection, when you use your notebook, you find that there are lines, so you try to use those lines because they are always parallel in your notebook. So here we are. So here we find that the image is formed, and this image is going to be what type? Let's see. We'll examine this. Here it is. Here we are. This was AB. So let's say this is A here, and this is B here. So ray of light going parallel, reflects back, again passing through F, getting reflected. So A is reaching at A dash here. So this is A dash, and B, it is the B, because this ray is going to be going on this principal axis and then coming back also on the principal axis. So again we find images over here. So this image is, if you see, slightly larger in size. It depends that where we have taken between C and F. Since we have taken it towards C, so image is not much bigger in size, but still it is larger. So it is bigger. Number one, it is inverted. This image is inverted. Secondly, since the rays of light are actually meeting at these points, so image is real. And the third one is bigger or larger in size, right? So these three things you must keep in mind. Then we move to our next case. The next case is at center of curvature of the mirror. So very simple thing is that it is here only. So here we find that the object is placed at C itself. So let's say this object is placed here like this. So once again same parameters we'll use. Firstly, to start with, we take this parallel to principal axis. So we have taken this parallel to principal axis, and after reflection it is going to come back through F like this. Second, we pass it through F. So we pass it through F, and after reflection slightly. So after I think we have to correct it because otherwise we may have some error. Be very careful. You must use your scale very carefully here. So we go like this. So we pass it through F, and after reflection it is going to go parallel to the principal axis. So when it goes parallel to principal axis, it is reaching somewhere here. So if you see here, the image formed is just up like this. So if your pencil is sharp enough, you will find very sharp diagram emerging. So here it is. So if it was A and B, so B becomes here B dash, A remains here only. So this is your first ray of light, parallel, passing through F. This was second, passing through F and becoming parallel. So here the image is real because actual these rays of light are meeting, so we can say image is real, number one. Then same in size, no difference, very important. And third one, image of course is inverted. Inverted means upside down. So the third one is inverted. So these are the parameters which you must draw carefully. Then we move for our next part, that is D. A little beyond center of curvature of the mirror. Okay, fine. So this is center of curvature. So object is slightly away from this C. Let's say we take object over here. Object is here. So again we go with the same sort of alignment. We going like this. So this is coming parallel. And after reflection, it is like this coming here. Third thing which you can use is you can pass it through C also, but then we'll use the same parameter. We'll pass it through F. So pass it through F, and subsequently we make it parallel. So it becomes parallel to principal axis. So image is somewhere here. So here we find that firstly, this is one. This was the object. Let's say A and B. So here we get the image. So first ray going parallel to the principal axis. After reflection here. Second passing through F, and then after reflection coming here, and image formed is smaller in size. Well, you can use other parameters also. If you see here, that let's say use another. We pass this B from C. So if you pass B from C, here it is. Slightly we have to go further, I believe, because there's not enough space. But if you pass it through C, you will find they will be converging somewhere here only, right? So you will find the object over here is firstly AB is going to now form this image as A dash B dash. So image is inverted, B dash and A dash. Here the line ray of light is going same on the principal axis and coming back also on the same path. So it is going to, A point is going to be here as A dash and B is going to be represented here as B dash in the image. So the image is number one, since they are actually meeting these lines, rays of light. So image is real, smaller in size. Yes, it is smaller in size. And thirdly, it is inverted, upside down. So this image is inverted. So we note it down for your exam purpose. And lastly, when object is at infinity. Infinity means that rays of light, they are coming from a very far off place. So when they are coming from a very far off place, we presume that they are parallel only. Rays of light are considered to be parallel. So this is one ray of light like this, maybe another ray of light like this. Another ray of light can be coming from this or from quite far off place, infinity that is. Then another may be like this. So you may draw an nth number of lines as you find possible. And after reflection, they are passing through F. So this goes from this place. This will be going passing through this place. Again, this is going to pass through F. So through F. And again, this is also going to pass through F. So here you find the image formed is at F itself. So all these rays of light we show. So this is one ray of light after reflection passing through F. Another parallel ray of light passing through F. Another parallel ray of light passing through F. Another parallel ray of light passing through F. So image formed here is at F, very small in size and real. Small, much small in size, rather very small in size I should say. Then of course rays of light, they are converging at this point. So image is real, and at F that image will be at focus, main focus. So this is how you can make all these figures very carefully. Rays, be very careful about various dimensions. With this we finish our question number 1. We start with question number 2.